Hello everyone, welcome to this lecture. So in this lecture, we are going to learn how to perform simple regression in PyTorch. Now, PyTorch is one of the most important library of a deep learning. And over the last 4 years, 70% of the industry is using the PyTorch as compared to other deep learning libraries. So it is very important to learn PyTorch. Therefore, we are starting from the scratch and we are going to implement simple regression. Now, student, here, if you can see in the screen, I am in my Google Colab. This is my Google Colab, and this is the lecture 5 of the series. So in lecture 4 of the series, I completely explain you how to use the Google Colab. So if you don't know how to use the Google Colab, so it is very, very important to go through the lecture 4 first and then come back to this lecture 5 of the series so that you can understand how to use Google Colab, how to import the data in Google Colab, and how to run the code in Google Colab. Okay, so if you see here, this is my Google Drive and I'm going to run this file. And in this file, I will import this data. So the data set and the file both are present in the same folder, which is the requirement to use the Google Colab as I explained in the lecture 4 of the series. Okay, now if you see right now, you can see the theme of the Google Colab is black here. In the lecture 4, it was white. So you can easily turn your theme from light to dark. And it is very easy. For this, you have to go to the tool and then click on the settings. If you click on the setting, you can see the theme. Here it is dark, light, and adaptive. You can select any. So I have selected dark here. So that's why the background is dark. Okay, so this is a way to change the theme of the Google Colab. Okay, so in order to get the data set and in order to get the code of this lecture, the link is present in the comment. If you go to the comments, you can see the link of the data set and the link of the code, and you can easily download there and then upload to your Google Drive, and then you can run the code. Okay, let's time to start this lecture. So first step is to import the torch. Torch means that we are going to use PyTorch. So we have to import the torch. Inside the torch, there is NN. NN is a neural network module. Since we are going to implement a neural network with the help of PyTorch to perform the simple regression, therefore we are importing torch.nn as NN. Now this is NumPy, Pandas, Matplotlib. These are very simple libraries. You have seen these. And now from matplotlib, I am importing a style. Now this is not important to import the style, but if you want that all the visualization and plotting which you are going to do in this lecture should have a dark background as well. So you can import style equals to dark background. So let me run this. If I run this, these libraries will be imported in my Google Colab environment. Now it's time to import the data, and I'm going to use regression underscore data.csv. So that data is present here. Now, if I have to import it, so this is a CSV file which I will read with the help of pandas, and the function I will call it read underscore CSV. So if I run this cell, you can see I am getting an error to no such file or directory. Even though we can see that the file or directory is present, then why we can get an error? The reason is that we are in Google Colab, and in Google Colab, in order to import the data, we need to mount the drive and we need to set the path. So this I have clearly explained in detail in the lecture 4, that is the lecture before this. So if you do not understand, I am explaining you here, but it is strongly recommended to go through lecture 4 first. Okay, let's see how we can remove this error. So I have to mount the drive. In order to mount the drive, I have to move here on this tab. You can see that if I put my cursor there, the tab is mount drive. If I click on this here, if I put cursor here and I click on this, you can see from Google Drive import drive, a code has been generated. So I have to run this code. When you run this code, it will ask you to connect to the Google Drive. So I have to connect it, and then I have to select the account. And after that, I have to press the continue. And then you can see after a few seconds, the drive will be mounted here. You can see that it has mounted here, and it will be appear here as a drive. Previously we can see there is no drive, and now you can see a drive has been appeared. So your Google Drive has been mounted. So if you click on this drive, now inside the drive you have a my drive, and if you click my drive, then you can see all your folders which are present in your drive. So here I am in the deep learning folder, and this is my drive. Definitely in your drive, it will be different. And in the deep learning folder, I can see this is PyTorch neural network. And inside this folder, there is a regression dataset present. Since this dataset is present in this folder, this is the innermost folder where I can get the data. So I have to go to these three vertical dot. I have to click on this. I have to copy the path, and then I have to paste this path here. So in order to paste the path, I need to insert another code cell. So if I click on this, the code cell will insert it. And then in order to set a path, I will press a percentage sign. Then I will write a CD space, and then I will copy the path which I have copied from here. So if I run this, the drive has already been mounted and the path is set. And now if I run this, you can see I have successfully read the data. The error is gone. So these are the important steps in order to know that how to import the data. So two important things are to know how to mount the drive and how to set the path. As I told you that I have already explained this in the previous lecture of the series, which is lecture 4, and this is lecture 5. Okay, let's see what kind of data we have imported. So if I run this, it is a very simple data, because we are going to perform simple regression. If you see, we have only 30 samples from 0 to 29. We have only 30 sample, and I have two columns, that is independent data and dependent data. We know in simple regression there is one quantity dependent, there is a one feature, and the dependent quantity depends upon one independent data. So independent data is a feature and dependent data is a target value. Okay, now I have 29, I have 30 samples of independent and dependent data. Now what I will do is I will call it as a X, that is a feature, and I will call dependent data as a Y, which is a target value which I have to predict, which is the definition of a regression, that in regression we use independent data to predict the dependent data. Okay. So what I will do is that the column independent data, I will save it as an X. I am using dot values dot reshape. And if I run this, it will be like this. So why I'm using reshape -1 and +1, and why I'm using these values? So basically this file is a CSV file, and I have read it into a pandas data frame. So this is a pandas data frame. So that dot values will convert into numpy array. You can see here the data type is array. If you do not write these values here, then in that case it will be in the form of data frame. Okay, so we need to convert it into arrays, because later on we have to convert it into a PyTorch tensor. Okay, then I am calling dot reshape -1 +1. So that is basically to transpose the data into the column form. If I do not write reshape here, you can test it. So that all will be printed in a raw wise. Okay, the next step is to get the dependent data, which is y, in the same array form. Now I have x and now I have y. I have only one column in a x, which is a simple regression requirement. And now what I can do is that I can visualize the data. In order to visualize the data, first I am creating a figure of size 12 by 6. Then I am creating this scatter plot from matplotlib. Okay, and the color is blue here, and these are the labels. So if I run this, now you can see that the plot has been created here, and you can see that this plot, we have the blue dots, we have x quantity here and we have y quantity here. So this is a scatter plot of the data, and we can see that the x and y are linearly dependent. They are showing a strong correlation, and they are rising together. They show linearly dependency on each other. Okay, now the most important step is, since we have to create a neural network in PyTorch, so all the data, that is x and y, should be in torch.tensor. Right now, these data sets are in the form of numpy array. You can see the data type array for both x and y. So the next step is that we have to transform into PyTorch tensor. The step is that we have to call a function tensor on a torch, and then we have to pass x and y, and we have to convert this torch.float32. This is a data type. So if I run this, both x and y will be converted into a torch tensor. And now if I want to see x, you can see the x has the same value as the previously. Let's scroll up and you can see that x here is in the form of numpy array. And when we scroll down here, we can see the x is now in the form of tensor. Similarly, y has already also converted into the PyTorch tensor, which is necessary to use this data with a neural network that will be created with the help of PyTorch. The next step is to create a simple neural network. Because we are going to perform a simple linear regression, you can see here we just need one neural network layer here. So this is nn.sequential. Sequential is a method of creating a neural network. NN is the module which we have imported from the PyTorch. NN.linear is the first layer. And you can see that the one show the input and this one show the output. Because we have one input feature, we have one column in X and we have to predict one value at a time. So this is a way to define NN.linear, that is a fully connected layer in neural network. So that is a very simple neural network and I am calling it a model. If I run this, so here we can see the model summary. It has only one layer and its input feature size is 1 due to this one, and its output feature size is also 1 here. Okay, so in this way, we have created a very simple neural network using PyTorch. How PyTorch? Because we are using NN, and NN we have imported, you can see here from the PyTorch. If we go very first step, NN is basically torch.nn, that is a neural network module in a PyTorch library. Okay, so neural network has been created and we can see it's a very simple, just one layer. Now set the parameters. So the parameters are that the learning rate is 0.001. We have set a very, very small learning rate so that it should learn slowly. Similarly, the loss function is MSC loss, and optimizer we are using is SGD. SGD stand for stochastic gradient descent. And here we are passing the model dot parameters, and learning rate is equals to learning rate, which is here 0.001. So these parameters are set. Now we have to train the neural network. For training, I am going to train it for 5001 epochs. And here I am creating a losses. This is zeros. This is like the empty matrix here. And then I am running a for loop for 5001 time. So what happened for every epoch, because this loop will run 5001 time. For every epoch, one loss will be calculated and that loss will be accumulated here in this losses. So in that case, what happened is this for loop will run 5001 time and I will get 5001 value of losses that will be stored here. So if you see for the first time, when I pass the data to the model, I will get the model prediction. Then I will compare the prediction of the model with the actual label of a data. I will get the loss function and that loss will be stored into this empty matrix. So in this way, I will be able to get 5001 value of the losses. Now the next step is that in order to train a neural network, I have to perform the backpropagation. So these three steps, optimizer dot zero grade, loss dot backward, optimizer dot set step, these are important protocols step which are necessary to perform the backpropagation. So what happens is when we write optimizer dot zero grade, it's initialize the gradient to 0 and it will restart after every loop. Then we have loss backward. So we back propagate the loss towards the layer of the neural network. And here we have the optimizer step. So in this way, this is all set to train the neural network for 5001 epochs. And the last step is if we want to print the training here, that how neural networks work. So what I have done here is that if epoch divided by 100 is equal to 0, so after every 100 epoch, I will see what is the value of loss. And we are expecting this loss should be decreased, because if the loss is not decreasing, it means the neural network is not getting training very well. So I am going to click it here and you will see it will train very fast because a neural network is very simple here. So let me run this. If I run this, you can see that it has training. When the epoch is 0, you can see it has a very, very high value of a loss. And this loss value continue to decrease. And when we are at a 5000, it has decreased very much as compared to the first value. Now, if I want to see what has been predicted here, this ypred is the value here, what is predicted by a model when we pass x to the model. So if we see the ypred here, you can see that ypred has a tensor because we have converted all the data which passed to the model into the form of PyTorch tensor. And you can see here the gradient is attached. The thing is, the back propagation during the training, the back propagation attach the gradient to the predicted value. So we have to remove this gradient so that we can use these ypred in our calculation. If we do not remove this, then it will be difficult to plot these value or to compare it with the actual value of y to calculate any matrix for the regression. So if you see here, this is a ypred and this is the back propagation. So during back propagation, gradient is attached to the ypred value. So in order to remove this gradient, if I write detach here, ypred.detach, you can see by writing a detach, there is no gradient value here. And before detach, we have the gradient value here. Okay, now the next step is we want to see how loss decreases as the number of epochs increases. So we will have to plot the loss versus the epochs. So if I run this cell, now you can see here, the loss is decreases very rapidly and it has reached to a very small value here, approximately towards 0. You can see that this is 10 raised to power 9. So loss was very high and it suddenly drop to very small value, and then it continuously decreases slowly, and when our 5000 epochs are completed, the loss value is very less as compared to the loss at the first epoch. It means training has been done successfully. The next step is to calculate the weight and bias of a trained model. So in order to get this, our model 0 dot weight dot detach dot numpy. Now again we have to use detach to remove the gradient from the weight and the bias value, and then we have to convert them into a numpy. So this step will remove the gradient and the dot numpy will convert into numpy. Now they are our weight and bias values. Now with respect to weight and bias values, now we can test our model. The thing is here the data is very small. There were only 30 samples. If you see when I read the data, there are only 30 samples. So what happened? I have used all these 30 samples. You can see here we have index 29. It means we have 30 samples into the training. So no test data is left. But we do not need to worry about. What we can do is that we can create a test data. How to create a test data? We can use a linear space function in NumPy, and we can create a 30 test sample because we had a 30 train samples. So we can also create a 30 test sample between 0 and 11. Why I take 0 and 11? Because if I see the range of my data here, it starts from 1.1 and its maximum value is 10.5. So if I create a test data between 0 and 11, so it will be correlated with the training data. Okay. So here I create a test data and then I am converted into the column form using a reshape. The next step is I have to convert test data into the PyTorch tensor as well as I did with the training part. Then I pass the test data to the model and I get the prediction with the model. And now I am plotting the prediction of the model with actual data here. If I plot this, you can see here, uh, this is our real data and this is a model prediction. So if we see in a linear regression, a model is trying very hard to take all the points, to consider all the points, but many points are away from this line. But these points are not very far away. So this seems to be a good model. And we are going to now check the metrics and evaluate the model performance. If you see the plot here, I use blue squares to plot the actual data and then I plot the test data as compared to the test data and the predicted data. And I also use detach because every time we get some data from the model, because if you see this yt is from the model, every time we get this data from the model, we use detach to remove the gradient. Okay. The last step is we need to check the performance of the model. So we use three metrics: root mean square error, RMSE, mean absolute error, and R2. So if I run this, you can see that the value of R2 is 0.86. Now, R2 is a normalized scale and its value is always between 0 and 1. So if the R2 value or the R square error of your model is close to 1, it means it is a good model. And if it is less than 0.5 or close to 0, it means it is not a good model. So we can see from this visualization as well that this is a good model and it is trying to approach all the data points. On the other hand, if we see here, our R square value also suggests that our model is a good model. Now, mean absolute error, MA value is also small. And if we see RMSE value, it seems very high. But why it is a good model if RMSE value is very high? The thing is, the RMSE value is always compared with the value of Y. That is the value which we have to predict. If you see here, it is in 4 digits, 9997. And if I scroll up and see the value of Y here, you can see the value of Y, which we have to predict from X, it is in 5 digits. So RMSE, and sometime here it is in 6 digits. So RMSE is 10, or for few values, it is 100 times less than the value to be predicted. Now, what does it mean? It means when your model will predict the value of Y, which is in 5 digits or in 6 digits, it is producing an error of 4 digits, which is sometime 10 times or sometime 100 times less than the predicted value. So this RMSE value is always compared with the output value, that is the value of a Y. But the best metrics to observe is this R square value, and you can see that that value is close to 1. So in this lecture, we learn how to perform a simple regression with PyTorch. And PyTorch, as I told you, is one of the most important deep learning library. In this lecture series, we have learned about the deep learning, and we will start with the regression, that is from the scratch, from a very basic application of a neural network. We will keep moving on. In the next lecture, we will perform again a regression, but that will not be a simple, it will be a multiple regression. And then we will move toward classification, then convolution neural network, and we'll move on to the state of the art deep learning model. Thanks for watching this video, and I will see you in the next lecture.